All right, so 5b is going to be multiplying, adding, and subtracting radicals. I'm going to start off with adding and subtracting. So adding and subtracting are really going to be the same rules. And we'll work on the first problem here. So we have, first thing you're going to do is simplify each term individually. So we have 4 square root of 98. So I'm going to take 98 and think about what the biggest perfect square, since it's a square root, I'm going to be thinking about what's the biggest one I can divide out of 98. 98 is not one of them, so I'm going to look at like halfway. And so 49 is about halfway. So 98 divided by 49, that does work. That's 49 and 2. That's the biggest perfect square that divides out of 98. Now I'm going to look at 72. So my next term, 72 is 36 and 2. Now I'm going to simplify what I have here, what I broke up. So I have 4, square root of 49 is 7, square root of 2. And I have subtract 6 times square root of 36 is 6, and then the square root of 2 left over. Now we're going to multiply 4 times 7 is 28, square root of 2, and 6 times 6 is 36, square root of 2. So when we were putting these together, we're looking at like terms. Like terms means you have the same exact, really it's everything after the coefficient. So after the 28, it's a square root of 2. We have 28 square roots of 2. And we're subtracting 36 of them, 36 square roots of 2. So if I had 28 and I subtract 36, I am going to have a negative 8. And what do we have? Square roots of 2. Negative 8 square roots of 2. All right, I'm not going to actually do this one for multiplication. It's quite complicated compared to what you have to practice, so I'm not going to work on that. So I'll work on number 1. I'll do certain problems throughout this, otherwise this might be too long. So the first thing we're going to do, we're going to simplify with adding and subtracting. So square root of 27 is 9 and 3. Square root of 12 is 4 and 3. Square root of 9 is 3. Square root of 4 is 2. Now, we definitely want to talk about, like I have a 3 times 3 is 9 on the outside. That is not, it's not always the same number, and 2 times 2 is 4 here. It just so happened to be that. So we have 9 square roots of 3, and we're subtracting 4 square roots of 3. When we do that, it's going to become 5 square roots of 3. All right, number 2. We have cube roots here, so we got to think about perfect cubes. So 54, that's going to be cube root of 27 and 2. And then 2 cube root of 2 doesn't simplify. And then 7. We have cube root, and we actually, with cube roots, you have negatives. Because like negative 2 cubed is actually a negative 8. So if you take the cube root of negative 8, that's negative 2. That works for all the cubes. I'll always take a negative with it, because that'll come out with it. So now simplifying each term even further, cube root of 27 is 3. Cube root of negative 8 is negative 2. And the cube root still is of 2 on the inside. Now let's keep going with this. 3 times 3, multiplying your coefficients, is 9 cube root of 2 minus 2 cube root of 2. 7 times negative 2 is a negative 14 cube root of 2. Now, looking at our like terms, we have cube root of 2, cube root of 2, cube root of 2. And we have 9 minus 2 is 7, minus 14 is a negative 7 cube roots of 2. And there's our final answer. I'm going to skip 3. We're dealing with fourth roots. I'm not going to work with that right now. All right, number 4, we have square root here first. And that is going to be 4 and 7. And we have a cube root here in the middle. So that's going to be, I think 8 is the, so it's negative 8 and 7. And 175 is 25 and 7. So we have 10 square root of 4 is 2 square root of 7. We're going to bring a negative 2 out. Cube roots of 7. Minus 4 square root of 5. 25 is 5 square root of 7. Multiply your coefficients on the outside. 10 times 2 is 20 square root of 7. Minus 2 cube root of 7. 4 times 5 is 20 square root of 7. So we have 20 square roots of 7, and we're subtracting 20 square roots of 7. That's 0 square roots of 7. 0 times the square root of 7 is 0, so those go away, leaving us with negative 2 cube root of 7. All right, let's take a look at number 5. Looking at our individual terms, 98, we've done that before, is 49 and 2. X to the fourth y squared minus 3x squared y square root of 2. Square root of 49 is 7. X squared square root is x squared. Square root of x to the fourth is x squared. Square root of y squared is y. And what's left is a 2 minus 3x squared y square root of 2. And then we have 7. So when it comes to variables, everything after the coefficient has to be identical for you to put these together when it comes to radicals. So we have 7x squared y squared root of 2. We're subtracting 3x squared y squared root of 2. So we're left with 4x squared y squared root of 2. All right, number 6. Don't be intimidated by this multiplication here. That multiplication is really pretty useless. Like, it doesn't even, it's the same as if it's not even there. So let's not really focus on it. It's implied that it's multiplication, any number on the outside when there's no operation in between, so it's always a multiplication. So cube root, negative 40 is negative 8 and 5, and a to the 7th, 2a squared, 135 is 5 and 27. So 27 and 5, a to the fourth. Cube root of negative 8 is negative 2. Cube root of a to the 7th is how many groups of 3 can you take out of 7? Well, that's 2. So that's a squared that comes out. And don't forget about the a that's going to be underneath. So we have 5a left underneath the square root. And then plus 2a squared times cube root of 27 is 3. Cube root of a to the fourth is, you can only take one group, so a. Cube root of 5a left over. I'm just going to clean this up on the outside. I'm looking at my first term here, and I cannot simplify anything. I'm just going to rewrite it. Second term, I can simplify some things. I have a 2 times 3, that's 6. And we have an a squared times a, and that is a to the third. That's a cube root of 5a. Now looking to see if we have like terms. We have negative 2a squared cube root of 5a, and we have 6a cubed cube root of 5a. If you have a squared and a cubed, those are not the same. So those are not anything we can do to put together. Very, very similar, but they're not the same, so we cannot put them together as one term. All right, talking about the back. Multiplication. I'm going to first, when you multiply, so this is multiplication. First, when you multiply outside radicals, so there's a 1 on the outside times the 5, so 1 times 5. And you multiply inside radicals, but they have to be the same radical. That's the one thing, like both are square roots. So 6 times 8 is 48. X to the fourth times x to the fifth is actually x to the ninth. Let me actually write this out. So 6 times 8, and then x to the fourth times x to the fifth. And 1 times 5 on the outside is 5. 6 times 8 is 48. X to the fourth times x to the fifth is x to the ninth. Square root of 48 simplifies. So once you multiply, you always look to simplify. So 48 is 16 and 3, and x to the ninth. So we have 5. Square root of 16 is 4. X to the ninth, how many squares can you take out? How many pairs can you take out of 9? And that's 4. And the square root of 3x left over. So when you take that 4 groups out, that's 8 total of the 9. There's 1 left over, so that's why there's 1 inside. So 5 times 4 is 20. X to the fourth, square root of 3x. Final answer. All right, I'm just going to go down the row here. I'm going to do number 13. Cube root, we don't have any coefficients on the outside besides 1. You can write the ones on the outside if you want, but no need. We have a cube root of negative 3 times 36, a to the 7th times a to the 6th, b to the 4th times b squared. So we have negative 3 times 36, 30, 18, so 1 negative 108. A to the 7th times a to the 6th is a to the 13th. B to the 4th times b squared is b to the 6th. When you have like bases with multiplication, you add exponents. So the cube root, oh, don't forget the cube root, Mr. Johnson. So 108, I know I did this earlier, is divisible by 27. So we're going to break this up into the cube root of negative 27 times 4, a to the 13th, b to the 6th. Cube root of negative 27 is negative 3. A to the 13th, we're taking the cube root, so how many groups of 3 can you take out of 13? And that is 4, so that's going to be a to the 4th. Don't forget about the 1a that's going to be left over on the inside. Now b to the 6th, how many groups can you take out of 3? Because it's a cube root, and that's 2. Oh, b, Mr. Johnson, b squared. Square root, the 4 is left over, and the a. And there's nothing to put together, so that's our final answer there. All right, now let's look at binomials multiplying out. We have a monomial times a binomial, so we're going to distribute square root of 10 times 5 square root of 5. So you'd multiply the outsides. 1 times 5 is 5. Square root of 10 times 5 is 50. And then square root of 10 times 2 square root of 2 is negative 2. Square root of 2 times 10 is 20. So multiplying those two out. Once you multiply, the next step is to simplify. 5 square root of 50 is 25 and 2. Square root of 20 is 4 and 5. Square root of 25 is 5. Square root of 4 is 2. 5 times 5 is 25. Square root of 2 minus 2 times 2 is 4. Square root of 5. Those are not like terms. Square root of 2 and square root of 5 are not like terms, so that's your final answer. All right, take a look at number 17. We have a binomial times a binomial, so we're going to take this 6 square root of 6 times the square root of 6. So that's going to be 6 square root of 6 times 6 is going to be 36. Let me just write out 36. Multiplying underneath the radical. And the square root of 6 times a positive square root of 2 is a positive 6 square root of multiplying underneath the radical is 12. Then we have a negative 6 square root of 2 times the square root of 6. It's going to be a negative 6. 2 times 6 is 12. Then we have a negative 6 times 2 times 2 is 4. Looking at simplifying each term, we have square root of 36 is 6, so we can just simplify that to 6. 12 is 4 and 3. 12 again is 4 and 3. And the final, we have 6 square root of 4 is 2, so that's going to be times 2. Let's look to keep simplifying. We have 36 plus square root of 4 is 2 square root of 3, and another 2 square root of 3. 6 times 2 is 12. All right, let's keep rolling. Kind of. There are steps you could have done to make this a little quicker. 36 minus 12 is 24. Let's see here. This is going to be 12 here. 12 square root of 3 minus 12 square root of 3 is going to be 12. If you have 12 squares of 3 and you subtract 12 squares of 3, those are going to go away. So our final answer is just 24. I had to goof up somewhere. Oh no. Maybe not. All right, moving on. 18. So square means the base times itself. So 4 minus square root of 5 times 4 minus the square root of 5. All right, multiply 4 times 4 is 16. 4 times a negative 5 square root of 5 is 4 square root of negative square 4 square root of 5. Negative 5 square root of 5 times 4 is negative 4 square root of 5. And negative square root of 5 times a negative square root of 5 is a positive square root of 25. Combining our simplifying each term or combining like terms, we actually have some like terms. Negative 4 square roots of 5 minus 4 square roots of 5 is a negative 8 square root of 5. Square root of 25 is 5. 16 plus 5 is 21. And there we go. All right, moving on, I'll do number 19. So we have a monomial times a binomial, so multiply underneath the radicals. That's all we have is 3 times 12 is 36. K times k is k squared. And then we have a negative 2. 15 times 3 is 45. K times k squared is k to the third. Simplify each term. We have square root of 36 is 6. Square root of k squared is k. We have 45 is 9 and 5, so the square root of 9 is 3. And k cubed is k. And 5k. 2 times 3 is 6k, square root of 5k. And we don't have the exact same terms, so they're not alike. And the last one, find the area. Area means multiply, so we got to multiply. 4 minus the square root of 6 times 7 square root of 6 plus square root of 3. 4 times 7 square root of 6 is 28 square root of 6. 4 times the square root of 3 is 4 square root of 3. Separate this out. Negative 6 times 7 square root of 6 is a negative 7 square root of 36. And negative square root of 6 times square root of 3 is a negative square root of 18. Simplify each term. The first two terms I cannot simplify, so those will just come down. We have the square root of 36 is 6, so negative 7 times 6 is a negative 42. 18 is the square root of 9 and 2. Square root of 9 is 3, so it becomes 3 square root of 2. And then I looked, do I have any like terms at all? I have 28 square roots of 6. Nope, I don't see any other square root of 6. I don't see another square root of 3. I don't see just a constant. And I don't see a square root of 2. So that's my final answer there. Now when it comes to perimeter, so this is area. Now perimeter, I need to add them up. So I need to have 4 minus the square root of 6 plus 4 minus the square root of 6 plus 7 square root of 6 plus square root of 3, and one more of those. I'm not going to fit this in. 7 square root of 6 plus the square root of 3. All right. We're adding, so we have 4 plus 4 is 8. We have negative 1 square root of 6 minus 1 more is negative 2 plus 7 is 5. So that's 5 square roots of 6 plus 7 more is 12 square roots of 6. What else do we have? We have the square roots of 3. I have 1 square root of 3 plus another square root of 3 is 2 square roots of 3. After I add those, is there anything I can put together? Nope, no like terms. That's my final answer. So this is the perimeter. All right. Thanks for watching.